Okay, so I think we can more or less start now. I know that there are many interesting sessions in the same time, so I'm very happy that someone. I was kind of scared to have nobody here. And so now the idea of this talk is something that, okay, these are the workshop, but I think we'll skip the workshop. So the idea basically is about the legacy code. How many of you are working usually with the big legacy code base? Okay, yeah, you are the right public for this talk. So basically, I'm going to introduce a bit of a technique that I'm kind of developed. They are a bit original, but about working with legacy code. And I hope you will find useful. And okay, so this is the usual legacy code ideal representation, something that really nobody wants to work with it. And I was myself like this. But yeah, I mean, when you work with legacy code, you usually have this kind of Dutch tape mentality where basically you don't want to touch the code. So every time there is a problem, you say, okay, this is the smallest possible thing that can fix the problem, even if it's horrible, even if it's just a copy-paste, something that you will never write in your real code, in your fresh code. But since it's legacy code, then we just do anything that can fix without touching. I mean, as less as possible. And then there are the big rewrite risk. Okay, this slide is maybe not very easy to understand, but I'm from Venice. And in Venice, at some point, they decided to do a glass bridge. It's joining two. I mean, it's not really so much useful, but they call a famous architect, and he projected this glass bridge. And basically, everybody talks about this glass bridge, but it's really terrible because Venice in winter is very cold, and there is always fog mist in the morning, and you can imagine a glass is almost without steps, so it's very, very smooth, it's very, very stylish, but almost covered in glass, apart from a little stripe in the middle. And yeah, I mean, the people also other people having a lot of problems. But this is just to say that having something new is not necessarily a good thing. It's not that since you have to do a bridge, you have to do this very nice glass bridge, very design, and then it's really terrible to use. And also in the software, when we have a legacy project, usually the typical answer is, okay, we have a budget, let's rewrite from scratch. And I mean, could vary, but usually, more often than not, the new one is not better than the one that we're going to replace. So what we are going to do, and basically, when I went to Japan, I found this very interesting tradition they have in Japan, which is called a kintsugi. Basically, the idea is that you have a precious object, for any reason it got broken. Instead of, so what you do, you can throw it away, or you can try to fix it in a kind of invisible way that is never invisible. And so what they did is that make the mend so nice that it kind of improve the object instead of detract from the object. And well, okay, they are in Japan, and this is the emperor, so they did with gold, and it's very, very nice. But the idea is that something that when I saw this, I mean, it came to me that maybe we can do something better also with our legacy code instead of just throwing away or just doing a very, very ugly Dutch tip fix. And thus I found a very interesting opinion about legacy code. And I think you know who this guy is. And yeah, I mean, at the end of the day, all the code is legacy code. I mean, legacy code is code that basically succeeds. Because if it's still hanging around, that means that it works. Because if it has absolutely no value, it will be thrown it away. And at the end, is a very small percentage of the actual code that has been written that arrive to the status of all the legacy code. Because usually legacy systems are quite good. Maybe they have other problems, but they are doing their job quite good. And so don't be too quick about disparaging legacy code. And yeah, this is a bit, same guy, is a bit of, punctilious things, but the difference between refactoring and code rejuvenation. And basically is that in a refactor, you want really to keep the same exact behavior when you change the code. So the idea is that you have some, let's say, good code, and you want just to change in a way that probably will allow you to add a new feature. But you keep at the same, so you said the behavior is perfect, I just wanted to change the code. Instead, the code rejuvenation is more like, the code is quite messy. I wanted to improve. I wanted to keep to the standard, to the modern standard, whatever modern means. But I don't want to, I'm not forced to preserve the behavior because, for example, there could be bugs that I don't want to preserve. If, for example, removing a possible null reference will change the behavior, but it's something that we actually mean to. So it's improving the code rather than keeping the, of course, the main use case, the main functionality, but not 100% identical behavior. So this is just an introduction of what we are going to do, but the idea is try to avoid when we work total rewrite and Dutch tape fixes. Instead, going to a progressive rewrite and the code rejuvenation. For progressive rewrite, what I mean is that instead of rewriting the whole application, you can start with a new application. Let's say if you want to go from monolithic Java application to, I don't know, what is microservices for whatever reason. And you can slice a bit of application, replace with a microservice, and keep the rest of the application. When this is OK, do the same again. I mean, do a rewrite, but doing a bit of a rewrite at a time. Or you can also do the opposite. I mean, you have a bunch of microservices that are impossible to maintain, and you wanted to have a monolith again. Also, hopefully a modular monolith, but I have all the code. But the idea is that planning your rewrite in a way that allows you to keep the old code. And OK, then we can decide when to rewrite, when to rejuvenate the code. I think the main point is that if it's possible to rejuvenate, just keep it to rejuvenate the code. Of course, if you want to change the language, if you want to change completely the architecture, you have to go to a rejuvenation, to a rewrite. And then it's OK. This is the classical discussion that I have when I talk about this stuff when friends or colleagues or stuff like that. And it's always the same. And someone is complaining about legacy code. Yeah, blah, blah, blah. The legacy code is terrible. Everybody really loves to complain about their code base, at least when programmers meet each other. And they say, yeah, but I mean, you can complain, but you can also improve. And they say, yeah, we know. And I mean, I can show you how. I mean, there are, yes, I know what to do. It's no problem. So you can start to improve your legacy code. No, our code is impossible to improve. Now, my point is that, OK, you can keep thinking this, But I really think that there is no code that is impossible to improve. So no matter how big is your code base, no matter how many problems they have, it's always possible to improve. The only thing that, of course, you have to think about is that you cannot improve everything in one go. So it's not like, OK, let's take 2 weeks and fix everything. It's a slow process, and you also have to learn how to do that. And the other thing is that it's not something that I mean, you have to take some risk because you can minimize it, you can try to improve, but of course it's something that you need to change the code. So if you are in a kind of company where the policy is never touch the legacy code, there is really nothing that you can do. But if the idea is to improve, it's possible. And OK, this is a bit the usual anti-patterns. I don't know. How many of you know about the anti-patterns? OK, yeah, basically it's the opposite of pattern. Something that is typically came out in legacy system, and which is not a good thing. I mean, they came out, but not in a good way. And just to give you a quick definition, because maybe you know for sure, even if you don't know the name. Stovepipes is that some system that has a very, very similar, not just a class, but a big piece of code which is flow that are very, very similar with minimal difference. And of course, in legacy code, it's quite typical that, for example, I'm working in a financial institution, and someone came to me and say, we need this for interest rate swap. And then, yeah, but I have no idea what an interest swap is. I said, yeah, it's like equity swap, but with this is different. OK, so you take the code from equity swap, you do copy-paste, and then you type. And this is how the stovepipes came out. So in a big legacy system, you have a lot of this kind of stuff. And the lava flow, instead, is another typical anti-pattern, which is, the lava flow of a volcano, that at some point in the old system, doing configuration with XML was, this is a typical example, was a very cool idea. So let's write all the configuration using XML file. And you go and you write, and you reach maybe 90% of configuration. And then someone say, oh, no, this is too old. Now everything must be done in JSON because XML is really, really bad. We like JSON. So, OK, you start from the beginning, and you start to change your configuration in JSON. And then you go like 50%, and then someone came and said, JSON is so old, and now there is YAML. I mean, you save a lot of space without those brackets. So let's rewrite everything in YAML for the configuration. So now you have a bit of configuration with all the configuration files, a bit with XML, a bit with JSON, and stuff like that. And this is the lava flow of the current, CV-driven development, where everybody wants to use the latest hype and framework. And another example is called a shotgun surgery. That means that you have a legacy system. Someone asks you, I just have a minimum stuff. You just want this field to be 4 decimal precision instead of 3. So you think, ideally, OK, I just needed to change a piece of the code. But then you go to the code base, and you start your test, you simulate. And you discover that you have to change 25 pieces of code, completely unrelated on the code base, because each one was doing some assumption of the dimension of that field. So just changing that field here force you to change a lot of other pieces of code that are potentially completely unrelated. And this is kind of a shotgun surgery. So every time you need to change something, you have to touch so many pieces of code, which is, of course, is very bad things. And then, yeah, the old good God class when there is some class that is very difficult to understand. So people are really, really scared to improve or to remove code from there. So it keep adding and adding, adding, and the class and the piece of code became really, really huge. I mean, I saw some piece of code with 2-3 lines of lines in a method, and 90% of those are completely useless, but nobody was exactly sure which 90% was, so everything was still there. And then, of course, there is the famous catch-22. You know what a catch-22 is? Yeah, okay. The catch-22, which is this book, which, by the way, is a very good book, and is a kind of situation where it's paradoxal. In the books, basically, it was this pilot of a big bomber on Second World War, and basically didn't want to go to the war. And so if you are crazy, you are not allowed to pilot the bombers. But if you don't want to pilot the bombers, you are not crazy by definition, because it's smart, I think. So it cannot be proven to be crazy if he doesn't want to fly the bomber. And then it's the same thing. So when you open these nice books about the refactoring, everybody say, okay, first thing, write the unit test. But if you try to write a unit test in a bigger code base, you have a lot of problems, and usually you are not able to test things in isolation. So how can I refactor the code to the unit test if I'm not allowed to use the unit test to refactor because cannot. Yeah, and this is a kind of typical catch-22. And of course, you can do something, but you basically will try to have some technique that works in a way that even without the unit test allow you to change the code. But it's just a kind of temporary solution until you have some code that you can unit test. And then once you should usually, you should really use a unit test when you can. So the idea that I came out was this kind of alchemical rejuvenation, that if you have to work in a bigger code base, I more or less did this stuff working with the bank, and you have to touch this code. And the idea is that, okay, I wanted to take just a bit of a chunk that I can manage, me or my team can manage of this big application. I wanted to make it in a separate module. Whatever module means can be a different application, but can also be a module, logical module, something that is independent. And I wanted to do cleanly, testing and everything. But once you have separated, you can clean, and then you can write a very good code there. And then if you have need to, you can also do another piece of code. Okay, about the name. When I was thinking this stuff, I was reading this book, which is a very, very nice book. I'm not going to read the documentation, but just to say that alchemy at the beginning, in the Middle Age, was really, really like a bleeding edge science. And at that time, also, alchemy was a very good. It has a kind of theoretical concept that was, they had experiments and stuff like that. Of course, at the end, they proven wrong. But the original idea was quite good. At least it could make sense. And they did a lot of practical experiments. They discovered a lot of elements and chemical. And also, at some point, there was so many people doing alchemy that someone was completely, charlatan, people that really don't know what, they're just trying to make, to get money, just a trickster. And some people who are doing real serious stuff. And at some point, they decide just to change the name and say, the serious stuff, let's call it chemistry, and let's keep alchemy for the old stuff. But until then, and in the Middle Age, alchemy was still a very good science, in a sense. And the idea of alchemy was that you have this kind of spirit in the metals, and if you take a kind of dirty metal and you purify it, you finally get the gold, which could be quite an interesting way, and it's more or less what we are trying to do with the legacy code. So this is just about the name. So what are the steps? Let's say that you have a big legacy project. So the first step is something that people forget about, but the first step is simplify the onboarding. So if you have a legacy project, you really want to be, and a legacy project that needs some work, simplify the onboarding, because typically legacy projects are very difficult to start with. I mean, you have to explain. Maybe it's not your case, but in the case that I work, you have to explain to people how they have to set up the IDE, how they have to do this and this, and prepare the machine, set the variables, stuff like that. I mean, it could take hours, it could take days to be able to, it could take days maybe because the compilation files is very complicated or getting the sources is very complicated. I don't even know how many house-made compile tools I saw in my career. All very, very bad copy of Maven or Make or whatever that someone at some point decided, now we have to do our own. So first step is make it easy for people to work with. So if you have a recipe, it could be a wiki if it's something simple, could be Ansible, could be Docker, can be a VM, something that you have a new guy, you put, you say, follow this step, and it's able to work on the legacy code in hours. And this is quite important also for them. And the second point is to have some end-to-end test. So I'm talking about a classical situation where basically there is no test, or if there is some unit test because at some point someone wrote some unit test, they are completely forgotten. They are testing just a very small part, or they are testing with so many mocks. I don't know how many people were here in the session before. I mean, that was very interesting about, having too many mocks can really defy completely the point of unit testing. So you can have your tests that are always green, whatever the actual result of the code is. And so what we really want is some end-to-end test that, so some input with some output, and then we compare. And it could be that they are nice tests, but sometimes they are not really nice. Like we have a dump, I execute, and I have some reports, some stuff that I also store. And then I just repeat this operation and check the dump if something is different. But it's not something that I will call a good test. It's just something that gives you the security that we are not changing anything. But maybe it's not the kind of acceptance test that you dream of. But just to make it work. And to do the next step is splitting modules. So you want to get a slice of your application small enough to work with. But for a slice to work, it must be a kind of vertical slice, something that goes from input to output. We don't want horizontal modules like UI, model, database, or persistence layer, reporting layer. We want vertical layers, like one use case, another use case, another use case. That can use, of course, a shared part of code, but the idea is to have the module something vertical. So you have your small module that you are working on, and you don't care about the rest application, and you can do everything in your module. Instead, if the module are horizontal, you cannot do anything with just the persistent module, so you need to use the whole application. And at the end of the day, so you have your module, and now you can start refactoring, because now everything goes well. And it's not tidy at the end of the day, maybe. And you can start with another module. At least if you have two. The point here is that it's not something that you have to do all of them. You can stop at any point. Even if you just stop after you did your end-to-end test, that can take, realistically, can take also some weeks. And it's not some wasted weeks, because you invested some weeks to have some tests that before you didn't have. So you have some information. I mean, you deliver some value to the business. It's not something that you did just as a pure investment. You also have some value return, because those kind of tests can be used by QA, can be used by next developer every time you want to change something. And this is the visual recipe, just a very small step. But let's go on the code. Now, this was originally a workshop, but well, if someone wants, you can do, but since we don't have so much time, I think I'll do the workshop by myself. And you can stop at any time and stuff like that, and you can look at. So everything is on GitHub. You can do yourself later at home if you're interested. This is just a workshop to show you mainly these 4 techniques that we'll use to be able, basically, if I go back to the recipe, the idea is to split the stuff in modules. So when we split the module, we don't have a unit test. So this is the main goal of these techniques. And this is just the rules. So I call the techniques with some fancy names from alchemy. And the first part of the alchemy is called putrefaction, dragon putrefaction, something like that, which was basically I don't know what it was, to be honest. I never did alchemy. But the idea here is to destroy singletons. The first problem when you want to do some modularization of your code is get rid of the dependency. And the nastiest dependency that you can have are singletons objects, which are just called from inside the code, and you really have no clue until something broke and you have no clue why. And these are basically the rules for the first. The idea of this refactoring is that something that you do without unit tests, so it must be something very automatic. Basically, the idea here is that once you identify a singleton, for singleton here, I mean something like, that some piece of code that without any, you call a singleton object using get instance or something like that in any point of your code. It just got in, or can be injected by Spring if you use Spring or something like that. And this kind of singletons, which is, to be honest, is not exactly what the singleton pattern was about, but this is what singletons are in our industry now. Some of them are stateless, and some of them are stateful. So the stateless is that the one that basically you can call as many times you want without changing anything, and which are quite easy to change, usually to remove. Usually you just need to instantiate them when you need, and then pass to the point where they are used. And using basically dependency injection rather than just have the reference in that point. The stateful ones, which typically is something like database connection pool, shared cache, or stuff like that. Of course, it's not so easy. What I find quite useful is having an application context, which is more or less like the frameworks work. Spring or stuff like that. They do kind of magically, but at the end of the day, they have this big singleton application context that you can call in any time. But just that if you do yourself, I prefer to have this application context passed explicitly to each function. So let's do the code. So this is our main. If I run this code, this is a conflict of there's a okay. I don't know. Anyway, basically, this kind of code, what is getting this produce a report where take some, don't look at the code, don't look at any, no, don't look at the code, but don't look at the data, don't look at the fake formula that I put, which is really completely garbage. The idea is that you have some kind of report about some traders. And the main here just take the kind of a fake connection pool and the fake printer and then produce the report. And if you say this seems also nice code, but it's anything but. And so the code here is organized in four. You can see, yeah. Can you read? Yeah. So basically, it's organized in four packages: commons, market, report, and risk. Now, what we want to do is just fix the risk one, and we wanted to do something clean. We want ideally to put in a new module, but we don't want to touch market and commons because they are used by other potential applications. And if we look inside basically this produce report, using this risk calculator, which is the main, the main class that will go to refactor. Is using a lot of this helper, config, and stuff that we really don't want to have in our own project. But first, so we wanted to remove this. But first we get to remove the singleton. And this is what I mean for singleton, because this get instance can be called in any point of the code, and it will be very hard to, it will be always a hidden relation between modules that we don't want, and also make it impossible to test, because of course when we are in a test environment we don't have the actual connection to DB. So the idea is that here basically we just try to apply automatic refactoring. For example, in this case I just remove this and put as a parameter, and IntelliJ is nice enough to also suggest some quite sensible name. And that's, yeah, I remember that there was another one, yes. And also here we just has a connection pool. So basically here we add this we just pass as a parameter, basically. And when we go back to main, yeah, basically here it will get the instance. And what we want to do, of course, we want also to remove from here and pass as a parameter also here. Actually, one thing that we can do is first introduce a variable. So the ID suggested to change the both of them. And then tell the ID I want this as a parameter. So in this way. In this way, everything has been done by the IDE, so we can just rerun the main and be sure that we haven't broke anything. Yeah. And this is more or less what I mean with, also, I did also some tests, actually. Yes, this is, no, this is not a test. Sorry. No, not this one. And this is I did a very small test, and basically the test is just calling the report without doing anything, just comparing the result of what he was expecting. Okay, so we have a few tests which are okay. And so now this is more or less how we want to do for the singleton. So basically move all the singleton. I think we have another singleton if I remember correctly. Okay, there's and for smaller stuff, we can just pass as a parameter. Is everything okay? The code, yeah. So now, once we transform all our singleton in some parameters, basically, and of course, I mean the parameter pop up till some point because when you have more or less to the main of your module, that could be the main of the project or maybe a bit lower level, but not inside the module itself, just at the entry point of the module that we are working on. At that point, you have a singleton. But it's OK. So basically, the idea is that the singleton inside your code, the singleton is just an object instance. But outside your module, it will be a singleton. So you can use the same between different modules. But inside your module, you just treat it as an entity that arrived from the beginning. And now the second point, which is more tricky, is that, OK, now we have a OK, this is the other one, basically. This connection helper is the kind of a stateless singleton that I was talking before, which is just been initialized here, which also is not such a good idea, because if I wanted to test a risk calculator with the different connection helper for whatever reason, I cannot do that. So what I can do, and it's the same with the config helper that is reading the configuration from the resources. Maybe I want to do something different in my code. So I basically this is not an automatic refactor, but I can basically ask this to add as a constructor parameter. And then it suggests me to put and as a default value, I can put and I can also do the same with the config helper. So if I put this as a parameter in the constructor, if I select correctly at least. So basically now, his calculator has some, I can rerun the test, and of course now I just need to import. Yeah, it works, but now his calculator has has a different main, basically. So it needed those two parameters. And at this point, let's go back. OK, so we more or less get rid of the singleton at this point, and we can go to the next step. OK, the next step is how to split. This is the most important step, basically how to split the modules separate. And the idea here is that we wanted to create an interface and then put all our code behind that interface. Well, there are two ways. Either we put all our code behind that interface, or we put the rest of the application behind that interface. That depends where our code is comparing to the main. But it is to have an interface that separates our code, our new modules that we are going to split from all the rest. And having an interface here as the main point is that we can definitely have a contract. It's not improving the code per se, but it's having a contract. What is this module depend on the other? Once we have the interface, it will be much easier than to do any kind of refactoring. And this the idea is that with the interface we avoid some breaking, involuntarily break this contract between these modules, because if we have an interface, then we can use the interface in the test. So if someone changes and introduces a new dependency, that will break the test, at least. So what do we have to do? First, we have to identify what we want to insulate. So the concept of the interface is that, I can also speak a bit about alchemy. We have this, in alchemy, there was this idea of a hermetic seal. And the hermetic came from the god Hermes. And it was mercury, basically the metal mercury. And hermetic also means something that is really closed very well. And that this really came from the alchemy, because it's something that you really want to contain without letting get out. And the same things we wanted to apply to the code. So first we needed to identify what we wanted to seal. Then we create an interface around those stuff. And then we do an implementation of the interface with exactly the same code that we had before, just that now is behind the interface. So our new module doesn't look at the stuff. And then we can start working on that and try to have the interface as little as possible. And then at the end, we clean up. Because once we have the interface, it becomes quite easy to do some cleanups, because we can easily see what we are depending on, and we can try to reduce the dependency. We'll see. For example, just to give you, instead of our code depending on the configure manager, we just need the 3 parameters. Okay, we can just pass the 3 parameters instead of passing the whole configuration manager. And this is exactly what we are going to do. So this is kind of the critical stuff. And we can easily also see here, because we have this nice import Gammasoft is my company, this commons. And what we can do is something like, for example, all this stuff in red now is stuff that we want behind the interface because they came from this common stuff, and we don't want our code to directly have a dependency on commons. Everything must be hermetically sealed by the interface. So this is just a trick to see what is. I think also it's possible in IntelliJ to somehow, I don't know. Well, there is a way to identify. So what we want is for the first things that we need is this two stuff, to connection helper and the config helper. So we need an interface that at least return this two. And okay. Sorry, I haven't tried if someone. Yeah. Extract. No. Okay, there is a way, but we can do manually. So basically, the idea is that instead of having these two methods, we have some interface that we can call like common interface or something like that. And then we are going to create the interface. And we know that we need those two, so we can get something like okay. So now we have this common interface, and we can just okay. This is kind of better, but of course, once we have the interface, I mean, we can just keep the interface as a field instead of having these two. So we want probably to do something like this, like this. And then, I mean, so okay, this was an old something that we need this common interface here, and then we need to be passed here. Okay, I think now we have broken something. Yes. And yeah, we have and still something else. Yes. And then here we have the. So now we are at the main level. And At this point, of course, we need to create the interface. And we need to put all the code where it was. And of course, we don't have we need to implement the interface somewhere. And we can call something like common context or something like that. And then we create the interface that implements the interface. And then, so connection helper was no, connection helper was just a new connection helper. And config helper was also a new config helper. No, it was a config from resource. Yeah. But okay, so here also we need for the test, we need a new common interface. Let's put it directly here. Then we can pass it around. Yep, and then should be something else. Yeah, this test we cannot ignore for the moment because it's not really useful. Okay. So now that we have, it's quite easy to see that. If we go back to the main. It's quite easy to see that, I mean, this connection pool instance should also be part of the common interface. And so we can have something like and note that at the beginning we need to open the connection before calling this moment. So we can think about putting the connection pool instance in a variable, and then maybe with a better name. And then we put the connection pool inside we can put a connection pool inside our interface. So we can just go back to. And at this point, I don't need to pass the connection pool instance around because I have already the interface. So I can just delete. But of course, I need to pass the common interface. And no, actually I don't, because I already passed the common interface in the constructor, the risk calculator, so I don't need the common interface when I call risk calculator methods. I can just remove the collection pool from here, and instead common interface. And I didn't put that. Oh, yeah, okay, I put in the class, but not in the. Okay. So now it should work. And then so here I need the connection pool. And I can also remove from here. And finally, no. Yeah, and then I need to pass the common interface. The connection pool. And remove from the test. Yeah, this is things is a bit annoying, but it's still quite safe. I mean, we didn't touch anything. And then the next thing is that now we know that everything that we need from the common stuff is behind the interface. So if we see that everything is related to the interface. Everything comes from the interface. Now, the next step is actually look at what we actually do with the interface. And there are two things. One is the connection, and we use the connection in several places. And the other thing is the configuration, and we use the configuration to get this config manager that is used inside the configuration here. And but the strange thing is that at the end, all the configuration manager what needed to do is get this parameter risk, which is also, I mean, of course I did this example, but it's quite typical that you pass an object and at the end you discover that you just need a very few times to use that object. So we can start to, okay, think instead of passing all the configuration manager, we can just pass this parameter around. And so we can say, okay, let's put as this config, and then have this config as a parameter. And so, yeah, I need now. I don't want this config. This config is a mapper, but I want the exact stuff like. So, okay, so I need this two. No, it was correct. Sorry. And I need these two, so volatility and bump, let's call. And we can see that in the main now, we have the common interface, and the rank calculation. Where it is. So okay, so exactly this is what. So basically, I'm getting the resconf here. What I want to do is instead of getting the resconf directly from the common interface. So having the common interface give me get resconf. And then in the, of course, I needed to implement. When I implement, I just copy basically the code that I have before, and this was the get configure. Oh, yeah. Yeah. Yeah, I got them. Yeah, I was using. I got confused. Sorry. This happened also as well. Let's see. Yeah. Also, the other thing is always never forget to commit only when the tests are green. Don't commit. Worst case, you go back to the last one. And yeah, but now I see that we don't have so much time. So the idea anyway here is to keep doing, to substitute all this stuff inside your interface. I wanted the code anyway to work, but don't want to spend much time. It's a nice exercise if you want to do all of them to the end. Risk calculation. Yep. Okay, this was the tricky part. Okay, so this was okay. This was what I was missing. It's not finished, but yeah, you can imagine like you keep doing and keep simplify the interface. Okay. Yeah. So now another technique that I also find quite useful is that when you have a lot of classes that each reference each other, and it's very hard to understand what will be kind of the best solution to simplify the code, because you're not sure how to I mean, you can go back to the whiteboard and try to figure out, but if the class are already working, you probably don't want to do that. You want to just to simplify the way that they are working because it's clearly too complicated. And basically the idea is quite simple: to identify the class that you want to do, remove all the method in the class and put as a static somewhere, and then put it back to the class where they belong more naturally. And I want to show you. And we can look at the other package here, the report. Basically, the report has just 4 classes, but each class more or less references all the others. So we have a risk data, the actual report, the printer, and the client data. And the idea is that basically, for example, report require the printer and the risk data, and printer require the string, but also to printer report require the report. So it's quite complicated how will be the better way, and the risk data is requiring client data and the response. Okay, risk data is quite simple, and there is not much that we can do. It's just the static, immutable object. But report, printer, and client data are quite complicated. So the idea here is to basically, instead of having this as, for example, in client data, we have these two as constructor. Sorry, I didn't stop, but if there is something that is not clear in the code, but yeah, just let me know. Just as a constructor parameter, basically, and since there is only one method, we can pass directly as in the method itself. There is actually no point to have as and also risk data. Was directly.
Is there a potential for unintended changes there? If you've got stateful objects, you've changed potentially the temporal?
No, because that was the idea. The idea is that since we are going to put as let's do with the report. We got to put as in a static object. So basically, I wanted to move this send to printer to a static. Okay, I need to create a new one, a new class, Java class that usually I call functions, just for the moment. And this is meant as a static class, so everything will be static. So if I move this to a static class, I'll do manually. The idea is that of course we need to have a printer here, So we need the printer as parameter, and also we need the risk data as parameter. And then create a string, also must be something that we wanted to move here and make it static. So the idea is that everything goes static, and the object became a parameter. So it should be no unintended changes. What does it say? That there is some. Yeah, because I refactored this one. So I actually think that let's leave as it was. Yep. And then yeah, so now basically instead of having L send to printer, we have a function send to printer L. And the risk data. No, the risk data. Sorry, this was. No, this was a report, it was not there. So then we can do. We just need to make it. So yeah, the idea is that yeah, a bit. And yeah, now it's working. And this is the same for basically for printer. We have this function printer that sends to printer that is held. So it's quite easy to understand that. Also, when we move this out and we move to function. This was from printer, so also we need to add the printer. We can see that actually this function of printer was just sending the report to the telling the report to send to the printer. So it's actually quite a useless function that nobody really uses. Because when we found someone that is actually using this one, it was just calling report send to printer. So we can do something like then send the printer. Where is printer? But then it becomes that is. that this actually is just, it's just calling a function that is not using printer at all. So we can just simplify and say inline the function and remove the function. And it's still working. And also, yeah, get lines, we can do the same. Put get lines that want an instance, of course. Then okay. Also, yeah, make it. So now when we need the data get lines, so this will be something function get lines with inside the client data. Now, it's a bit of an exercise. The nice thing is that at the end of the day, we have all the functions that we care here. And we can, let's see, so client data is done. This is more or less, it's not using, just using a string, so it's okay. Report is done. And risk data is done, so yeah. So we basically move everything here. We clean up one. And once we have this one is, it's quite easy to see that this function have to go to report because it's only one parameter of a type report. So this is his own kind of natural place to move. And IntelliJ should also have a way to do that in one go. And now if we go to report, we don't need this to be static anymore. Okay, so IntelliJ didn't do completely, but we can basically pull it back where it belongs. But some other function, for example, get. Okay, this was also more or less together with the report. And this also the only one that is in client data, so we can move back to client data. But the idea is that when you have multiple ones, it's much easier to understand where they should go. And if there are some kind of circular references, it's much easier to simplify them. And also, every time you do something like that, you can just run your own stuff. Okay, so basically, now you have center point is quite clean. And once you clean up everything, basically you have less dependency, and it should be much easier to put in unit test. And so the last one, okay, this is probably more useful in, not more useful, but it's more in novelty in Java, where the Lambda are kind of new stuff. If you are used to use Lambda since a lot of time, you know already. But the idea is that when you have two classes that are very similar, instead of try to do what you want to do is if you wanted to remove the duplication, the classical stuff was, okay, we can do an abstract class and then try to combine using template pattern, for example, the two classes together. But with the Lambda, we can just work at method level, so have a static method that take 1, 2, or 3 lambdas with all the differences between the two methods that we want to do, and then just work at the method level, and then having the two methods calling this static method with slightly different parameters. I hope I can show you this one as well. So basically, yeah, the idea is that this calculate value, present value, and value and risk are very similar. So the first line is completely identical. Then we have also this that fetch the exchange, which is completely identical. Then here we have a config conf. Here we don't. But so the idea basically is going line by line, find the one calculation. Okay, this is slightly different. And then just basically do a lambda around the stuff. I think we don't have the time to do also this refactoring, but I think you can try to do the exercise in the GitHub. There are also the solutions, so if you want to look at them. And yeah, so basically adding the lambda parameter instead of creating a new class, and then once you have a static method referenced by both, you can try to simplify. And the whole point of here is basically to try to have this kind of small refactoring that it can be, it's almost, done by the IDE in automatic. Once you have separated your module, you can start using the unit test. And once you have a unit test in place, you can start doing refactoring that really improve the code, because you are much more safe, basically. And okay, these are some common mistakes when we try to do this stuff. It's something that I'm working for a while, so I have some experience. One typical mistake is okay, we have a legacy code. We want to do some refactoring, and maybe we also get some investment or permission from the management to say, okay, let's do 1 month of refactoring. And then it basically 1 month wasted everybody trying to do something that thinks that is a refactoring, but it's not really improving anything. It's just moving stuff around. So first you need really to identify a strategy. What you wanted to achieve, which module you wanted to separate, what do you define exactly with separation, you wanted to be able to run alone or stuff like that. And just say, let's invest 1 month to have some unit tests, for example, which is also quite common. It's usually not a good thing, also because people, and this is also one other problem, try to use a lot of mocks. So you wanted to unit test legacy code. Okay, we need all these dependency. So you put a lot of mocks everywhere. So at the end, basically, we are just testing the mocks framework. And that's why also when we do this refactoring, the point of refactoring is not using mocks. So we can test without mocks. There is nothing wrong about mocks, just to be clear. It's just that you don't want to mock stuff that you don't own. If you mock something, then basically you created a mock of some dependency that you don't know about. You run the test failed for some reason, then you add the mocks in a way that make the test works. You really are not testing anything. You are just testing that the mocks are working as they're supposed to work. but it doesn't give you any information on your code. Instead, once you have, for example, done that interface that we spoke before, that separate the two modules, you can use mocks on that interface, because that's an interface that you created. You know exactly how it should be used, and then you can use mocks to basically return the value that you need for your test. Another thing is that when we do that kind of refactoring, you need to be more disciplined and never try to do more than one thing at a time. So if you are, for example, applying that interface, you shouldn't, in the meanwhile, also fix other things as soon as you see them, because that goes to that situation where you kind of lose. And at least you have to commit every time before, so you can go back to the last commit where you're safe. And the commit should be something like 15 minutes, 30 minutes, not 1 day, 2 days of work, because that it becomes very painful if you have to return. And yeah, I mean, doing here myself, I got lost concentration sometimes, so I had to redo. So it's something that you really want a nice environment when you do this stuff, because you have to keep very concentrated and try to do simple steps and never going on and again. Trying to fix one, yeah, try to write, never use mocks for stuff that you don't know. And never commit without the test. And this is also a kind of classical question. Okay, we have this bigger legacy code. Where to start to clean up? This book is very useful because basically it suggests some techniques and a framework to get your history from your currency system and see where the problems are, because usually problems is where different people work on the same file, or some commit that, for example, we talked before of shotgun surgery. If it's kind of typical for a commit to touch files, those 3 files together, that means that those 3 files are somehow related. But if they are in completely different package, there is something wrong if you keep changing these 3 files together that are completely in a different place. And you can discover some things. But when you discover this kind of problems, you should try to work one, and you have to work on one. You should try to get one of the real problems, because it's completely useless to try to fix something that really nobody touched or is working fine. But you don't want to do the most difficult one at the beginning, because this kind of techniques takes a bit of time to be proficient, to be confident to use them. The first time you do kind of a lot of mistakes. So I would suggest do something easier, but not completely useless. So try to. And yeah, the technique in this book are quite useful to give you some suggestion where to start. So more or less, this is all. And yeah, I'm interested. I'm really passionate about legacy code and good code. So any feedback, I'm really curious to hear. And yeah, maybe I'll write a book about it maybe one day. I don't know. Any question, of course? Okay, thank you very much for attending.